Okay, we're quickly going to get into a very brief description of linear equations. I know that you guys have done this in your previous math classes before. That's why we are doing this quickly. We're just going to take a look at this example over here. 9x plus y plus 7 is equal to 36. It can be any number. This is what we call a linear expression. X and y are our variables. They are letters that we put in place for specific numbers. Oftentimes x and y are used when we are graphing points on a coordinate plane. When we are evaluating expressions, we do PEMDAS, but we do it in the reverse oftentimes because that makes it easier. So you still do your PEMDAS. So you have to evaluate your expression the same way that we would evaluate an expression without a variable in it. And finally, whatever you do to one side, you do to the other. So that's a really important part. So if I was evaluating this expression over here, I'm going to quickly erase this so that it's easier for us to write. Okay, so I am evaluating this expression over here. I want to isolate the variables onto one side, or make it look like y equals, so we can have a slope intercept. So first I am doing the subtraction because we go in reverse order for our PEMDAS when we are evaluating expressions. So we do addition and subtraction first. So I am subtracting 7 from this side, subtracting 7 from that side. So it'd be 9x plus y is now equal to 29. So that's a 9. And then typically we want this to be in slope intercept form, which is y equals mx plus b. So I'm going to subtract my 9x from this side, subtract my 9x from this side. So our equation will be y is equal to negative 9x plus 29. So I get it into that slope intercept form. Then I can use that to be able to find x and y points on a coordinate plane to plot this line. So that's just some basics about linear equations, sorry. So now we're going to talk about the different terms that we use in our expressions. So multiplication, we can talk about it in times. We can talk about it, it's the opposite of division. So it's the opposite equation, and similarly, division is the opposite of multiplication. Sometimes addition is thought of an add, or and. So 6 and 7, so you're adding them together. And it's the opposite of subtraction, and subtraction is the opposite of addition. So these are just important for us to note what our opposite thing is, so that when we are evaluating our linear expressions, we do them correctly. Okay, we're going to take a couple look at some practice problems. We are going to do number 1 together, and then I'm going to have you pause the video and work on number 2 on your own. So in this, remember, we want to do that PEMDAS, but in reverse. So we are isolating the variable on one side. So first, we are going to subtract this 10. It cancels out over here, so now we get 3x is equal to 21. Then we are dividing by that 3. So our x is equal to 7. Okay, I want you to pause the video and try number 2 on your own. Okay, Hopefully everyone started with the opposite of subtraction. So we are adding our 9 to both sides. Now we have negative 4. X is equal to 30. We are dividing by that negative 4, dividing by that negative 4. So X is equal to negative 30/4. We can also simplify this into X is equal to negative 15/2. I think that leaving it as a fraction like this when it's not a perfect division problem is completely fine. Please do not feel like you have to find the exact decimal for every fraction. Setting it up like this is a completely reasonable answer. Box it and walk away. Okay, we are going to do one more together. Let's do number 5. This one has a little bit of more complicated. So we can't just subtract this 2 first because the 2 is inside of a parentheses. So first, because parentheses would be the last thing that you do because you do PEMDAS in the reverse. So first we have to distribute this 5 inside. So 5x plus 10 is equal to 20. Now we can subtract that 10. So we are subtracting the 10. 5x is equal to 10. Dividing by that 5. And x is equal to 2. In this example, 10 divided by 5 is a whole number, so that is why I did not leave it as a fraction and I divided it. Hope this was a quick refresher for linear equations and solving for x. We will go over this in class, and if you have any other questions, feel free to